We're gonna make the wait worth it. My name is Anthony Dels. I am with the Department of Transportation. I am the manager over our Engineering Workforce Development Division, newly formed. It's about 2 years old. That said, I have a little bit of bad news and some good news. See, I knew it would get quiet. You hear bad news? What's the bad news? Bad news is, yes, I am standing between you and lunch. That's, that's the bad news. The good news is I'm not standing alone. Super excited to facilitate this panel of students. They're going to be presenting to you some of their work or places that they work. You can see, if you look at the program, you can see a large portion of today has been dedicated to these students. So I just want to applaud Dr. Zaman and SPTC for recognizing these students and the effort that they put in and the value that they bring to what we're all here today, engineering workforce development. Well, workforce development. I just happen to be an engineer, and that is my focus. But throughout this, what you're going to see, I am confident that just kind of sitting over here listening, you're going to hear that a lot of these students are actually addressing some of the things that we're talking about right now today. So I'm excited to hear from them and present them to you. I'm honored to be sharing some of that work with some of these students. So let me not stand in the way much further. You get out of your way. We're going to bring up our first presenter, Fabrice Simpor. And if I said that wrong, forgive me. I'll let you correct it when you come up here. But Fabrice is a mechanical engineer student at the University of Oklahoma and a researcher in the Mobility Intelligence Lab, where he works on autonomous vehicle systems and intelligent transportation technologies. His research focuses on developing practical platforms that enable safe experimentation with vehicle control systems for autonomy research. In addition to vehicle autonomy research, Fabrice is involved in advanced engineering projects, including experimental optimization of high-performance 3D printing systems and collaborative engineering design projects at OU. He's interested in the intersection of robotics, artificial intelligence, transportation systems, with the goal of contributing to safer and more intelligent mobility technologies. One question, maybe two questions for you. What year are you in? I'm a senior. You're a senior. Do you have a job yet? He's single. He's available. So listen intently. He's free after this.
All right. So hey everyone. My name is Fabrice. I'm a senior mechanical engineering major, and today I just wanted to talk about MILA, our lab, which is Mobility Intelligence Lab. And we have the goal of cracking the code of SAE Level 4 autonomy. What that means is essentially, how do we get those cars on the road to drive by themselves safely? So that's the main goal. So this is our lab, led by Dr. Binchu. So we have a fleet of 5 different cars, 2 2025 Nissan Leaf, 1 Hyundai 2025 Ioniq 5, the original Nissan 2015 Nissan Leaf that we started with, and a support van. So we have a collaboration of teams. So we collaborate with undergrad students, graduate students, and also capstone teams with everyone working on different platforms. But of course, the goal is the same. How do we get those cars safely to drive on the road by themselves? So that's the main goal. So before any software can drive a car, like before you can take a piece of software and connect that to a car so that you can drive autonomously, you need to physically connect to it. So that's why in our lab, we developed a drive-by-wire kit. And what that drive-by-wire kit gives us is it gives us control over steering, acceleration, braking, turning signal, gear shifting, you can name it. So we have control over actuation. And of course, with that, so we have different ways of sending command to the car. So the first thing is using a blue pad, a gamepad, so you can bring your PS5 controller or an Xbox controller, and we can connect that to the car for manual testing. So we can actuate, we can steer, we can accelerate, we can brake, and show all of that during the manual testing. There is this thing called CAN bus, so we can also, it's the vehicle controller area network. I will touch a little bit on that in a minute. And so what that gives us is we can go into that communication system and send commands to the car. And the third is ROS, which is Robot Operating System. And the robot operating system is literally just a computer node that gives us access to the computer of the car, and we can send commands to that. So that's the different way. As you can see here, this is the drive-by-wire kit right here that we implemented on the 2025 Nissan Leaf. So what are we actually building at Miller? So we are working on 3 different stacks. And the first stack that I mentioned is the drive-by-wire kit. So we have a group of students developing the drive-by-wire. And what is actually happening is you need something that is reliable, something that can be transferred to different cars easily and safely. So we have a group of students working on that stack. And the second stack is end-to-end learning. And that is essentially how do we train a neural network, which is a machine learning model. How do we train that? And how do we get that neural network to take as input camera images and turn that into commands that the car can understand? So that's the second part. And the third part is reinforcement learning. So what we're doing here is we are getting the car to learn from an expert driver. So an expert driver will drive the car around and teach the model how to drive. So that's the third thing that we are working on. And what is my work? What am I actually working on? So my work is kind of at the intersection of software and hardware. So how do we take a piece of software and make it drive the car autonomously? And there is this software that I'm using called AutoWare. It's an open source stack that we're using. And of course, like for you to be able to get the software to drive the hardware, you need to do some CAN bus discovery. So the CAN bus discovery, as I mentioned, the CAN bus itself is a controller area network. So you can think of it as 2 wires inside the car that connect every single sensors of the car. And inside those 2 wires, there's information that flow through. So the CAN bus discovery section is, for me, is to understand what type of messages goes through those 2 wires, and do we understand what they contain? And that's the discovery phase. And once we understand the messages, we try to inject some custom commands into those CAN bus system. And of course, at the same time, when you're able to inject commands into that system, you're also getting control over the whole car controller area network. And the third thing that I'm working on is integrating the whole hardware to the software. So the software is an open source, so we are also trying to prove that we can use open source models to connect to a real consumer vehicles. And the goal, of course, is full autonomy. How do we get the car safely on the road to drive by itself? And that's the main thing that I'm working on, integrating that software and the hardware together. So what have we actually demonstrated with those vehicles on the road? So the first thing that is ongoing right now is unsupervised robotaxi. So we have a 47-mile round trip from Norman campus to OKC airport, lateral control. So during the trip, no one touched the steering wheel. So it's still ongoing, but very good demonstration. And you can see we don't have any problem driving during the day or at night. The car drives by itself autonomously. The second thing that we demonstrated is vision-based automatic emergency braking. So you take as input images from cameras and convert that into commands that the car can understand. So the car takes those commands and perform the automatic emergency braking. And we also have adaptive cruise control and point-to-point navigation. So how do we get the car to go from point A to point B by itself safely? So we build maps that the car can take as routes and is able to actually drive through those specific paths by itself on campus. And the third is teleoperation. The main goal of teleoperation is in extreme weather conditions or hazards, if a human driver cannot safely navigate to a certain location, then we can send the car to go there by itself, and it's much safer. So that's the third thing that we demonstrated. So we're still working on that also. And what's next for me? I will keep working on the vehicle hacking part of it, reverse engineering. There's still a lot to learn. Still want to know, how do we discover those messages inside the Canvas system? How do we send custom commands to the car? And how do we wire that to a software that can drive the car autonomously? And all of this will be at the intersection of physical AI. I want to understand, how do we take a policy model and train that policy model and input that into the vehicle control loop? So that's one thing that I want to continue working on. And I will be continuing with that as a PhD student at Mila. Thank you. Any questions? If you have any questions.
Yeah, how do you ensure the safety of this process? Like someone hack it from somewhere and then can control the car, and you have no, it will do something crazy for you instead of driving you around.
Yeah, so the reason we're working for so the SAE level 4 autonomy means you have to regulate with a lot of companies like transportation companies and also AI companies. So what we're working on right now is ensuring that safety. That's why those cars are not on the road yet. So the main thing, of course, is getting those regulations, complying with those regulations. So we're working on that. And you said, how do we ensure the safety? Our drive-by-wire kit that we're working on is giving us control over steering, acceleration, and braking. But for you to actually be able to control the car, you need to physically cut those wires and connect to it, which usually is hard to do. We don't really share those information with people, so unless you have access to the drive-by-wire kit and understand the whole architecture, which is usually, not everyone has access to it, so it's much safer, I think. Yeah. I don't know if I answered that question.
Any other questions? Oh, yes, sir. Oh.
Is there anything we can do to design roads to help this out, to make it better?
Sorry, can you repeat that?
Yeah, is there anything we can do when we're designing a road that would help this out and make it work better?
Yeah, so I would say one of the main things that we do is lane keeping. So if the lanes are well designed, if we can get those, so we're taking input from cameras. So if the camera can identify those lanes, it will be really nice. Because in some areas, it's really hard for the cameras, especially if you're driving and there's one lane on the right and on the other side is only a curb. It literally make it harder for the vision model to track those lanes. So if we can get those lanes on both sides, that would be nice. Thank you.
So to kind of expand on that question, what if the vehicles run up on a construction work zone? How would it handle a situation like that?
So that's why we're working on teleoperation, so we can control the car from anywhere we want. So if anything like that happened, let's say the car, I mean, we've been able to drive the car around construction zones, and it's been doing perfectly fine. But in case of like those situations, we are able to get the car to a safe location using the teleoperation that we have. We can connect to the car from anywhere and navigate the car safely to different zones.
I saw some other hands, questions.
We have a question from an online audience.
Okay.
This is from our virtual audience. Someone asked, when you have passengers, is anyone in the driver's seat for backup safety?
So the goal is to have no driver at the end of the day. So the level 4 autonomy of SAE is getting the car on the road with no driver. And for you to do that, you have to work with a lot of regulators from the transportation industry, and also, since we're using AI, you also have to work with AI companies and the government. So the goal is to get to that point. We're not there yet, of course, but that's the main goal. No driver, no human driver needed for the SAE level 4 autonomy.
All right, thank you.
Thank you. And I just have one little questions about your physical AI. I want to know what's your plan to inject physical information into the AI architecture? Thank you.
Thank you. So for physical AI, what I was really looking forward to is working with digital twins. So what I mean by digital twin is, how do we ensure that the simulation that we're running can reflect on the real car, and not just running the car just in simulation. So we're using, right now we're not really focused on physical AI, but one of the main things is NVIDIA Isaac Lab, where you can train robots in simulation and make sure that those simulated models that you're training can be transferable to a real physical robot. So that's the main thing that I was trying to track. And I will be trying to work on that during my PhD.
Other questions? Okay, just now I want by show of hands, how many in here 45 and up by show of hands? Okay. So Fabrice, all these hands you see up, I have a question for you.
Okay.
Would you be comfortable as a passenger in an autonomous vehicle? This is your chance to sell autonomous vehicles to all of us old fogies.
If the vehicle is proclaimed as a level 4 autonomy, because most companies don't just say, okay, this is a level 4, right? So if you're able to get the vehicle to that level, then yes, I will. And that's what we're working on. So we'll try our best to get the vehicle to that level, and once the vehicle is on that level, then we can safely say, I will safely drive that vehicle with no human driver needed.
You go first. After you, I'll go.
Yeah, so Anthony, thanks for handling the microphone. So I wanted to ask you about this new project that you have on the Rural and Autonomous Vehicle RAB project. It's a big initiative. I hope Dong is here, or maybe but anyway, what are your thoughts and how do you use that project to actually take this, what you just described in the Mila lab, to the next level that you have not done, right? And it's a great opportunity. It's there. We cannot stop. This train is moving and accelerating, right?
Yeah.
So how do you take benefit from that? Thank you.
So if I understood this correctly, so basically, most of the testing that we do are on real road, right? So we don't just do simulation, we work on the road. So we have designated area that we drive the vehicle to, like parking lots, where it's safer, of course, and we always have a human driver on the vehicle to make sure we ensure safety of the public, of course. So we take the car on those places and we train the models that we have. That's essentially the next step. That brings us to the next step. So not just work on simulation, but get that simulated robot or the car vehicle that you have and train that vehicle on the real world. And we're using, as I mentioned, reinforcement learning, where we have an expert driver that teaches the car in real time. And we had the unsupervised robot taxi, 47-mile round trip from here all the way to the airport. So we've demonstrated that we can take this work to the next level and bring the car on the real road.
Going once. Going twice. All right, thank you, Fabrice. Good job.
Thank you.
Our next presenter, as she makes her way up, Ms. Morgan Bynum. Morgan Bynum works as an assistant manager for the OSU Design Squad at the Oklahoma Department of Transportation, where she supports the design and development of roadway and bridge projects across the state. Morgan earned both her bachelor's degree in civil engineering and a master's degree in structural engineering from OSU. She is passionate about mentoring the next generation of engineers and contributing to the transportation projects that improve safety, mobility, and the reliability of infrastructure across Oklahoma. Morgan.
Well, hello everyone, and happy Wednesday. Thank you for the introduction. I'm obviously going to talk to you about the Oklahoma State University Design Squad today, and I'll just give a little background. Like he said, I'm the assistant manager of the OSU Design Squad. My boss looks like he just stepped away. Oh, here he is. Dominique Nguyen, and then obviously Anthony Delsey. So just a little bit of background. Like he said, I graduated in 2024 from OSU with my undergrad in civil engineering, and I just graduated, at least seems like a little bit too long ago now, with my master's in structural engineering in December of 2025. And fun fact, I played 4 years of college soccer at OSU during my undergrad. I'm washed up and retired now, but that's okay. So what is this design squad that everyone's talking about? So essentially, it's a partnership that OSU and OU, as you're going to hear in a little bit, has with ODOT. So pretty much, we employ part-time undergrads. So they work for us 20 hours a week along with their school schedule. So some of our students are in 12 hours a week or a semester. Some of them are in 18 hours a week. So pretty much we kind of give them that middle ground. We employ them as full-time employees. They work for us year-round. They get benefits, they get PTO, they learn how to use sick leave, all that kind of stuff. And in the last few years, we've kind of transferred to more of a training program rather than just a co-op because we had a lot of downtime. And we said, you know what, we really need these students to just be fully prepared when they get out into the workforce. So we work on real transportation projects, as you'll see moving forward. Like right now, we're helping Division I with some typicals, concept stations, kind of whatever they need. But we really focus on training our students, so we're shaping them into the employees we want right when they're graduated from school. So what do the students do? We work on plan reading and interpretation, probably one of the most important things as a transportation engineer, because if you can't read a set of plans, you're looking at hieroglyphics at that point. We do open roads, concept station, we do quantity calculations, which our lovely team at QAQC just developed a new set of Excel spreadsheets that I'll show you in a little bit. We do HYA, and ultimately, if you're in a DOT, you have to be able to navigate project-wise, because again, that thing is also very confusing. So we teach them that from a very young age. So this is kind of our plan reading and interpretation. As you can see, this is just a random set of plans that our students will get on their first week on the job. And this is something that I've developed over the last year, this like plan reading checklist. And ultimately, the plan reading has been developed because, and I can speak from this because I'm in this generation, with AI and computers, we've really lost our sense of detail. And because computers catch everything for us now. So we really teach our students to go through and look for the state highway number. Is that wrong? Because if we present it and the state highway number's wrong, well, that's not even the correct project at that point. So we really just break it down into super detail. They say, is it there, is it correct? Is it present, but it's not correct? And is it just not even there at all? So this is like probably way longer than the students like, but it's a pretty long Excel sheet that they go through all 300 and something pages of a set of plans. We also do Open Road Designer, teach them that from a very early time in the squad. This, for example, is Highway 51 to Kingfisher County, or between Kingfisher and Payne County, and one of our sophomores actually did this not too long ago. This is a training guide, but fun fact, I actually worked on this project 3 summers ago when I was on my summer rotation with Stillwater. We work on concept stations, and this is actually a real project that was asked to be done by one of our sophomores, Keely Dale. And out in Sarah, Oklahoma, she designed the shoe fly in concept station for her division that she works for over the summer when she goes back closer to her house. We are developing new open bridge trainings. We're not super involved in this yet, but we're hoping to get more into it, and we have a great training guide to start with. These are the quantity calculations that I'm loving right now. QA/QC did an amazing job because before we were doing them all by hand. And students, I'm sure you can attest to this, coming to work and doing calculations all day, they didn't want to do it. So this is just such a better way to have everything in an Excel sheet and really break everything down to the foot at that point. Oh, what just happened? Oh, this is HY8, it's just hydraulic design. We just hit on this just so they have seen it before they get out into the workforce. And then obviously, we all love ProjectWise. So why does this matter? I ultimately think the design squad is so good because they get such hands-on experience before they get out into the workforce. Yes, they may be doing training manuals, but all these training manuals are based off of real-life projects that have been done in years past. So we expose them to DOT standards, mainly Oklahoma DOT standards, but we expose them to that, and they work with people who are full-time engineers, and they get advice from people, or they get sent back corrections. So it really just builds their confidence and skills before they've even graduated. A lot of our people in the squad right now are sophomores and juniors, and I mean, we have a few seniors this semester, but think about it, they're gonna get 2 to 3 to some even 4 years of experience before they even work for us full time. So it ultimately just prepares students for the industry, and we get to keep them after graduation. So my role as a student engineer before I took my place last January, I learned design software from scratch. I worked on real-life ODOT projects. I developed plan reading skills, and I ultimately collaborated with a bunch of different people in ODOT as a senior in college. And right now, this is very unique, but my situation is I get to mentor students. I'm a young face that gets to relate to them, that gets to teach them, and ultimately just be that person that develops them so they can go out and do stuff. Like Dom, he's not old by any means, but I've just been there. I've done that. They can trust me, and ultimately I get to develop these training programs that I've done myself and worked with Dom to make better because I've already done them. I've seen the flaws. I've seen everything that doesn't really make sense, but we can make it make sense a little bit better. So, and I also get to work for ODOT, so it's awesome. But again, just as a master's student, I learned to balance life and my job, which is so funny because I actually bring it back. Being a college athlete, you learn a lot of skills of time management, learning how to get an engineering degree while also having 40-hour practice weeks. And I think the design squad is the biggest correlation to what college athletes learn. These kids are learning how to juggle 20+ hours a week, learning that, oh, school's out, you don't just get to go home for the summer, keep working. They are learning how to use sick leave. They're learning all of these things, again, before they even get out of school. So then it's just second nature once they graduate. So yeah, the impact. Faster learning curve. I'm about to start rotation in a month or two. I can tell you my learning curve through ODOT is gonna be a lot faster than someone who didn't have the experience in the design squad. We're giving them confidence. We're building their resumes, and we're getting immediate contribution, probably a week. We give them a week after graduation, but right after, they're already working for us. So, takeaways. The design squad, and for all you people who aren't from Oklahoma and you are a part of different state DOTs, I would encourage you to just even bring up the thought of a design squad in your state, because it's one of the best workforce pipelines I've been presented over the last year of working my job and talking to different people, because the students gain so much early on and it accelerates their growth. So all that being said, any questions are welcome, but yeah, I love the design squad and I can go on and on.
It sounded like you were interviewing for my job. Slow down. So before we start asking her questions, I'm actually going to bring up the OU representatives, because we have the same identical program at OU, and then we'll answer questions all at the same time, if that's okay.
Yeah, absolutely.
So hang tight. So I want to bring up our OU students, Mr. Damian Torres. Damian is from Oklahoma City and is currently a junior at OU, studying at civil engineering with an interest in transportation and roadway design. And then we have Ms. Nayeli, and if I say this wrong, forgive me, Pantoja? Okay. She's a sophomore civil engineering student at OU with a strong interest in infrastructure and transportation systems. She's currently working in the OU Design Squad as an engineering intern. In the summer of 2025, Nayeli worked as a summer engineering intern with ODOT. And during that time, she gained field experience observing asphalt pours, concrete testing, and inspections on active construction sites. Take it away.
Okay. Hello, everyone. As Anthony said, my name is Nayeli,
And then my name is Damian Torres.
and today we'll be presenting our experience as engineer interns with the OU Design Squad. So, a bit about me is I'm a sophomore here studying civil engineering, and I'm particularly interested in transportation engineering. So, last summer I had a summer apprenticeship with ODOT for the District 4 OKC residency, where I learned a lot about the transportation projects and how they were monitored. And so I'm now currently at the OU Design Squad. So here we get an exposure to transportation engineering design, so I feel like getting an understanding of both sides is super important for the development of our learning. And I'm also a part of ASE in SHEP.
And hello, Guy. Oh, dang, this is kind of low. A little tall. But my name is Damian Torres again. I am a junior here at the University of Oklahoma, studying civil engineering with a minor in construction science. I've been with the OU Design Squad for a year and a half now. And then a little bit about me outside of school and work, even though I have a little bit of time, but I try to make it count. I am part of the Oklahoma men's club volleyball team. Not D1, but close enough. So yeah, we practice like a few times a week. Not that big of a time commitment, but then we also travel to surrounding states and compete in tournaments against other club teams. And then also, I am also a brother of Omega Delta Phi Fraternity Incorporated. It's probably one of my most rewarding experiences. We put on a lot of conferences for first-gen students and give them a lot of resources for higher ed.
Okay, so about my summer internship, I spent most of my time in the materials lab performing standardized testing. We tested such as sieve analysis, asphalt burn-off tests, and soil particle size testing, which was really important because we realized that the materials needed to be verified with their specifications before being put into an actual roadway project. So, yeah, I also had the opportunity to see construction sites such as activities such as concrete pours and asphalt paving, and so I feel like seeing that helped us see how the materials we were testing were super important to do all that correctly, because it was going to be impacting our community. Like, we can't be inputting wrong material into our projects. So another part of the experience was that I was able to attend a professional event such as conference for the ASCE in Stillwater, and I also was able to be part of the Women in Transportation Tour hosted by the RE, Jonathan Brooks, for District 4. So here I gained a better understanding of how it is being in an engineering professional environment.
And then kind of to go back over kind of the software, it's kind of the same stuff that they do at OSU, But yeah, so some of the stuff we do as well is open roads, project-wise in OBM. Probably the hardest training for me has been learning project-wise. If you asked me the first months when I was working there to find anything, my answer would probably be no. But now I think I can find anything at the drop of a hat. So then, yeah, I kind of have pictures of kind of the stuff that I was working on in OBM. There I have a bridge right there. I really, really like OBM. One of my only critiques about OBM is it crashes a lot. So that can be a little frustrating. But then also I have ORD on the right. That one was actually a shoe fly detour that I was working on in there. Unfortunately, I think it got cut off when I was taking the picture. But then another thing again is Concept Station. I really like Concept Station. I'm a very visual person, and I think Concept Station is really fun. You know, when you're like on hour 4, hour 5 of your shift, being able to look at roads opposed to lines is always great. But right there, I was working on an intersection on a highway. We were including a right turning lane and a left turning lane to reduce crashes. And then again, with the plan sheet development, same thing. We're kind of given like a checklist to go through to make sure that everything on a title sheet is there and everything on a typical section is there. And then I was lucky enough to work on a real world project just now. I just finished it a week ago, finally. But it was a resurfacing project in District 1 on State Highway 2. Right there you can kind of see where all of the training kind of plays in. Whenever I was first assigned the project, I was kind of worried. I was like, I'm not sure if I know exactly how to do everything, but from the first day that I started it, I kind of realized how much all of the training kind of prepared me to take on real world projects. So right there I have a title sheet. It was still in the earlier phases, that title sheet, so not everything is on there. But then also I have my typical section. Something that I really liked was there's a painted gore in this project, and I didn't find out until like halfway through the project. But luckily, my amazing managers, Jay and Cassandra, were able to guide me through that project. And then again, I kind of spent I have spent all of my time kind of in the office. But over the summer, we take a lot of site visits, so that's really, really cool as well.
And for skills gained, I believe that one of the biggest takeaways was that we were exposed to both the construction and design phases. And we also gained experience working in engineering environments, particularly professional. And we also developed communication skills through collaborations, presentations, and meetings. And we gained a bigger understanding of the transportation field in general through all the experience that we are currently going through and we will go through in the future.
And also just to highlight again why this experience is important, one of the biggest ones I realized is I'm currently in transportation engineering, and I think all of the stuff that I've done at OBDOT kind of just reinforces all of the stuff that I'm learning in the classroom. So whenever we were learning about station numbers, I was like, oh wait, I already know how to do that. And then also it kind of provides a bigger insight into transportation infrastructure development. I think just learning kind of how to balance all this stuff and just like the construction phases and things like that, like 30% meetings, 60% meetings, learning a little bit more about that is super cool. And then also, I think one of the biggest things is just reinforcing the interest in transportation careers. I know whenever I first arrived on campus, I did not know that transportation engineering was even a thing. I had to take a class here called Exploring Seas to even find out about that. So I think that's really great. And then again, programs like this just help us further improve our skills before we enter the workforce. And that's the end of our presentation.
Thank you, guys. Give me a minute. Said I wasn't going to cry. Proud pop. Okay. Come on back up, Morgan. We take a lot of pride in this program. This program has been around since 1970-ish. And I think at OU it was in the mid-'80s when it started. But I just want to kind of show you some of the pride that's in the room. Anybody that's gone through the squad that's here today. Okay. And I want the managers to stand up. So for OU, it's Miss Cassandra Henson. Just stay. I'm not going to make you talk. She hates that. And Jay Joslin. All right. And at OSU, it's Morgan and Mr. Dominique Wynn. Okay. And I always communicate to them that you're not just training and developing engineers. These are somebody's children, right? And so we're training up young men, young women to be professionals in this workforce and in this industry. So it's bigger than just learning how to design a road or a bridge. We just give it more responsibility than that. And then I also heard that Nayeli's parents are in the audience. Can you wave at us? Thank you for coming. Thank you for coming. We love our students. We love this program. And Nayeli is one of my favorites. I know when we got her and we stuck her out in the field, I was like, how's this young girl with these fingernails going to go out here and test concrete and asphalt? She's like, look, they come off. They come off. So love her to death. But I'll shut up. Any questions for the students about any of these programs? Okay. Questions? Yes, sir.
Hi, thank y'all for that presentation. That was great. We're doing some similar things in Louisiana, and you'll hear later today the panel. We're talking about workforce development, as I guess the whole symposium is. But the question is, what's keeping y'all in ODOT and keeping you from going to private industry? And I realize I'm saying that in front of people who are at private industry too.
They've been trained. It's okay. They know. I'm standing here. They won't give the wrong answer.
I think the biggest thing is I've now worked for ODOT for about 2 years, and the opportunities I've been given, even as a college student, I think it's very easy for adults or people in the private industry also to just not take us as seriously because we're not technically engineers yet and we don't have certifications. But I think over the summer and during the year, ODOT makes us feel like we're full-time employees. And also, the pay that ODOT's now giving us is awesome. But that's ultimately what it is. I think a lot of people say once you're at ODOT, you kind of stay because it's a family. And I really think that holds true because, again, I've only been here for 2 years, but I feel like I've been here for 10. So.
I would just say, especially as of right now, we are balancing coursework and our training, and I think our managers, again, like she said, it's kind of like a family. We all feel very, very supported whenever we're doing our trainings, and it's just, our managers are really, really understanding. Like sometimes we have an exam, and sometimes I don't want to do my training after. But yeah, our managers are super duper understanding and just make us feel like we can tackle all of the training that they give us.
I agree with Damien about our managers being amazing, and also Anthony. They're all really helpful and being lenient with us. Like, for example, I asked Anthony if I was able to take, 5 summer courses this year, and he was like, yes, that's fine. So because usually over the summer I'm full-time, so I would do 40 hours a week. But besides that, also in the design squad, we also get our schedule that aligns with our school schedule. So it's really helpful having that experience, being an intern, being so young, but also bringing that onto the future. When we graduate, we already have a job that's secured for us, and I believe that that's really amazing for us.
Y'all gonna make me cry. Stop it. Stop it. Any other questions? Yes, sir. Oh, another.
So, being on the ODOT design squad, how do you feel like it has made it easier to be a student compared to other jobs that students would normally have during the school year?
Hello? Well, definitely, granted, I'm now full-time, but when I was a student, the niceness, I guess, probably not the best word, of having your office on campus. So you go to class at 8 a.m., you're done by 9, you're in your office by 9:05. Oh, I have class at 10:30, I work from 9 to 10:30, and that's kind of, you work and you're at school all day. So in the proximity of your office and being on campus. And I think that's why for other campuses it's so important because, I mean, let's be honest, the travel time, the scheduling, I mean, normal jobs, you can't just go work for an hour and then go to class and then go back for an hour, you know? So I think that's just overall why the Design Squad is such a great opportunity for busy students.
I think that's kind of the same reason, if I'm being honest. Having our office on campus is just really, really convenient. That way we're not having to, you know, drive from work to class. And I mean, OU parking is horrible. So we're already on campus. So that's really, really great.
Yeah, I agree with them, but I believe that one of the advantages is that we, in a way, work backwards, which is we actually apply the knowledge, but then we're also learning that in class. So compared to other students who don't have this internship experience, we're easily adapting to the program, such as like one of my coworkers, she was doing a capstone project, and she was like, yeah, I'm teaching my teammates how to do bridge designs, and I was like, that's so amazing. I'm barely a sophomore right now, but I know that all of this will help me one time, the junior and senior. So, yeah.
And just to be clear, here on campus, the office is right across the street from what they call the quad, where all the engineering classes are, so very convenient. And OSU, the engineering classes are on the second floor, the office is on the first floor. So that commute is very short and very appealing to the program. Any other questions? Hold on. The people online want to hear you.
Thank you. So the Design Squad, I heard all good things about the Design Squad, and I'm really glad Morgan works for the Design Squad and as the assistant manager. So there's so many things about you. And I got another question, because besides the students work for ODOT, are there training opportunities available for other students? For example, if I teach transportation, I just equations, right? But essentially in the work, we just use the software to do that. So our students only see the equations but not see the open roads or open bridges, project-wise, and so on. For other students, are there any opportunities? They do not work for ODOT maybe, but they work for the private sector and essentially will work for ODOT.
I like that, good question.
Hi, Dr. Lee. He was my transportation professor, so. Unfortunately, I wish I could give you a better answer. Right now, no. Do I think the Design Squad is just a foundation of what can be done in the future, whether that's taking engineering into high schools or creating training guides that you as a professor could use to push people into DOTs or just transportation in general? Yes, I think that would be amazing. Right now, we kind of keep them close to home. So, yeah.
And I'll also add to that, second what she said, but we're also available to actually come to classrooms. And so if you're teaching a particular section in your class, you want a professional to come in and talk to the class, it's a matter of going downstairs, knocking on the door, hey, we're talking about this today, you have a student, or you have some staff member that can come up and talk, or I'll come up and talk. One way or another, you have access to us. So we realize, they're getting special treatment, but we're willing to share. Any other questions? Okay, we got one more group I want to make sure to give. I could talk about this all day, and if they short, I'll come back. I'll fill up the rest of the time. I'll take us right up to lunch, I promise you. But I want to bring up the next group. Thank you, guys. Morgan, Damien, Ailey. Okay. Our last presentation is the OU Civil Engineering Capstone Bridge Design Group. And I won't spoil it. I'll let them tell you all about the project. Mr. Seth.
All right, hello everybody. We are Red Dirt Designs and we're part of the Civil Engineering Capstone Project here at OU this year. And our project is an actual Oklahoma Department of Transportation project that's located in Seminole County, Oklahoma. So before we get into the project, a quick introduction. My name's Jackson Ashford. I'm the project manager. Our hydraulics lead is Evan Nordhughes. Our structural lead is Seth Ray Smith, and he's assisted by Caden Smith. Our geotechnical lead is Elizabeth Pyle. She couldn't be here today, but she's assisted by Brooklyn Gow. And then our transportation lead is Axel Segura, and he's assisted by Claire Nolan. So a quick project overview. This is 6.6 and 6.7 miles east of Seminole, Oklahoma on State Highway 9, and our project length is about 0.44 miles long. The main objectives of this project are to replace a 60-foot span bridge over Tiger Creek, rehabilitate or replace a 54-foot RCB culvert on an unnamed creek, and then reconstruct the roadway to 4-hour clear zone requirements per ODOT standards.
All right, so moving on to hydraulics. In order to determine how the existing terrain would feed the streams, we use stream stats and their linear regression curves to delineate drainage basins. It was determined that Tiger Creek had a relatively flat slope of about 0.85%. Meanwhile, the drainage basin for Unnamed Creek had a much larger average slope of about 9%. It was also determined that our project lies within a FEMA flood zone, Zone A, giving us additional requirements to make sure that a design does not raise the base flood elevations for the 100-year storm. And as per ODOT design storm selection guidelines, we selected a 50-year flood frequency for our project. For our project, we use HECRAS version 6.6, and these models required various inputs gathered from our survey and as-builts, including flow data, as well as river cross-sections and various slope measurements. We also had to establish our Manning's end values, which is a very important thing for hydraulics that lets us determine the channel roughness. To do this, we use Cohen's method to allow us to account for irregularities, channel meandering, and brush and vegetation and such in the channels. Our proposed design for Tiger Creek, the relatively flat drainage basin, did not have any major hydraulic limitations or constraints. It was determined that our overtopping frequency was a non-problematic value of greater than the 500-year storm. And additionally, it was determined that our 50-year and 100-year discharge water surface elevations were well below our proposed bridge low chord elevation. Additionally, we are proposing a chute fly detour for this bridge. It is to be designed on two 48-inch diameter corrugated metal pipes on the existing ground slope on fill. We've opted to design around a 5-year flood frequency rather than the more common 2, because we've determined that our project site is a critical path leading into Seminole that leads to the only schools and hospitals there. So we didn't want it to fail at just the 2-year event. And it was determined that a detour of equal speed and quality would increase the route by about 29 miles. These pipes were sized in HECRAS to fail at our design year storm of the 5-year event.
So for the RCB culvert on Unnamed Creek, we had some hydraulic concerns that we needed to address. This included high velocities, hydraulic jumps. There's a lot of signs of scour on the downstream end, and the existing condition of the culvert. We determined that this was able to be rehabilitated. So we are going to be extending it from 54 feet to 70 feet, and this drops our velocities by quite a bit, which allows for less scour. The 2-year design storm has a higher velocity, which we are taking into account with a reconstruction of the existing drop outlet to a bigger size. This is our HECRAS model for that, and our 500-year overtopping discharge is, or the 500-year elevation is greater than the discharge of 3280 CFS for the 500-year storm. The 50-year discharge water surface elevation is 898.91, which is enough to pass that flow without causing major scour issues. Now, in that 2-year design storm, there's a hydraulic jump there, which could cause some issues for concern. So we're going to be upsizing the drop outlet to a 6-foot curtain wall, and the 8-foot curtain wall is actually just redone. We're going to do a 20-foot apron, give more space for the water, and then a riprap apron on the downstream side to further mitigate scour and any issues with that.
Our project runs from station 0 to 22, which is about 0.4 miles long. We chose the start location because there's already 8-foot shoulders that we can tie into, and the roadway needed improvements, so we are fully repaving the entire road. We chose the end location because of shoulder taper length and guardrail distance needed after the bridge over the Unnamed Creek.
The horizontal alignment mainly follows the existing alignment with 12-foot lanes, 8-foot shoulders, and a design speed of 65 miles per hour. The vertical alignment begins around Station 6, where the profile becomes relatively flat over the sag curve over Tiger Creek. After the bridge, the proposed profile remains flat until it ties back in to existing ground around Station 16. We also designed a shoe fly detour, which was designed for a speed of 35 miles per hour. This is to ensure safety and help reduce cost. It was designed with 12-foot lanes and is offset 50 feet south from Highway 9 center line to give enough room for construction and keep us away from the existing pipeline. The shoe fly vertical alignment is slightly lower than the Highway 9 proposed alignment. For earthwork, from Station 0 to 6, we follow the existing ground, so there's minimal cut and fill. From Station 6 to 16, there's primarily fill. And then from Station 16 to 22, we follow existing ground again, so there's minimal cut and fill. The shoe fly, however, will require a lot of fill. Because of this, we are looking into whether or not a nearby landowner would like a pond on their property. And if that works out, then we can use that excavated material as our shoe fly fill.
Now, so to maintain traffic during construction, a temporary shoe fly alignment will be implemented south side of Highway 9, specifically 50 feet south from center line to center line. The idea here is to shift traffic onto this temporary alignment while the existing bridge is being removed and reconstructed. In the case of the smaller unnamed creek, it does not require a full detour. Therefore, we will be using stage construction, which means that one of the lanes is going to be open for traffic while the other one can be worked on. In this case, flagging operations will be required in order to maintain safety. Also, a reduced speed will be implemented through the work zone, reflecting a 35 miles per hour design speed. Again, this is also to maintain safety. Now, at this stage, the vertical profile was refined in order to minimize cut volumes and unnecessary grading. But most of the roadway will remain consistent with the existing grade, and small deviations will occur mainly at the bridge crossing. Now, the existing profile contains a sag curve near the creek crossing, but this was a problem because it reduced the side distance for traffic approaching the bridge. So what we did was that we raised the road in order to improve this available side distance and also maintain the existing profile along the rest of the corridor. For the temporary shoe fly alignment, we selected a 35 miles per hour design speed using ASHRAE Green Book criteria. On this table, you can see how this resulted in a super elevation of 4% and a side friction factor of 0.18, which at the end resulted in a curve radius of 371 feet. Now, there are 10 residential driveways that connect directly to Highway 9, and they will remain in the same position, but they will be reconstructed where the proposed roadway differs from the existing grade. There is the one driveway on the south side of Highway 9 that will, specifically between stations 13 and 14, that will require minor right-of-way acquisition due to the temporary shoe fly alignment. But this is not a problem because we will use tie-ins in all driveways in order for the owners to access their properties at all times. Also, we evaluated the need of retaining walls and sound walls during the preliminary design. However, due to cost considerations, we decided not to include it in this design.
All right. For the dimensional considerations on the Tiger Creek span bridge, we have an existing 60-foot length. It's a single-span bridge. We extended that out to a 75-foot single-span length to clear the existing spread-foot abutments. We had an existing 26-foot cross width that we expanded to a 40-foot cross width with 8-foot shoulders to meet modern ODOT standards. We had a 902 starting elevation on the west end, but for stopping sight distance, we lifted that alignment 4 feet, so it is now a 906-foot starting elevation. We had an existing 2% longitudinal grade. We were able to maintain that at about a 1.9% longitudinal grade. For the material changes, we have existing 6 W33 by 141 steel beams. We kept that number of beams, but we moved to type 3 pre-stressed concrete girders to maintain capacity as well as for comparative ODOT projects. We had steel guardrail on the existing. We updated that to TR4 concrete railing. And with that, we had existing pipe drainage along the sides coming down. We opted to go for the slot drainage under those TR4s.
For this portion of the project, we have proposed the rehabilitation of the reinforced concrete box over the unnamed creek. This is based on our on-site visual observations of the project and some hammer testing based on specs from ODOT. And choosing to rehab the bridge provides a more cost-effective solution that reduces the time of construction and reduce impacts to traffic and concurrent right-of-way. For the rehabilitation, we will be reestablishing the head wall after we add 8 feet of typical RCB section to both the upstream and downstream side of the box. This meets for our zone standards, which lengthens our total length from 54 feet to 70 feet, as they mentioned earlier. Additionally, after the extensions have been made, we will be reconstructing the wing walls, the apron, and the curtain wall with typical sections as well. The curtain wall will be dropped down to 6 feet, and the aprons will be 20 feet in length. Additionally, during construction for life extending measures, we are proposing, with cost in mind, to recoat the surface of the bottom of the RCB box for hydraulics. And then additionally, during construction, any found exposed rebar will be treated and coated for future corrosion mitigation.
Our site consists of a Vamusa formation, so that includes sandstone and shell alternating layers. But we also have zones of chert conglomerate, and specifically in the bedrock for our borings, it was found to be silty sandstone, and bedrock was hit at 23.5 feet from boring 1 and 7 feet from boring 2. And we also got a high TCP blow count, which means that the rock is moderately hard to hard. So we calculated a design resilient modulus with, it was 4,700 PSI with a wetter optimum moisture content and a stress deviator of 6. And then groundwater was not encountered during the first drilling. It was later found at 19 feet and boring 1 and 16.5 feet at boring 2 from the ground, so going down.
For the existing State Highway 9 asphalt, it was deemed that there was a 4 to 6 inch asphalt depth with an 8 to 10 inch aggregate depth underneath it. There was existing cracking and stripping, so we knew that there would have to be at least a 6 inch depth of asphalt on any proposed design. For that, we had a design life of ODOT standard of 30 years, and we had flex ESALs in this mix for 2 million ODOT ESALs. The asphalt was an 8 inch depth with one 3 inch S4 lift on top of 2 3 inch S3 lifts. The aggregate base was 8 inches on top of another 8 inch subgrade. We use a standard PG70-28 binder. For the shoe fly, we had a design life of only 2 years during the construction phasing. So the ODOT Flex ESALs were only just over 100,000. We had a 6 inch depth on the asphalt there, 2 inches of S4, 4 inches of S3, on top of a 4 inch aggregate base. And we used the typical temporary construction binder of 64-22.
So for our bridge foundation, we're using driven steel piles that are HP 12 by 53, and we have 4 battered and 3 vertical. And because our borings, the borings are 107 feet apart, so we had to do some linear interpolation to figure out what we needed for the pile length because our bridge is only 75 feet long. And so we found that we needed 5 extra feet on our piles, and also we have to account for being 5 feet below the creek flow line. So at the west end, it's 29 feet, and then at the east end, it's 30 feet.
For the environmental considerations, we had 4 species of concern. We had the red knot, the piping clover, the whooping crane, and the American burying beetle. Of these 4 species, 2 were of major concern, and those are the whooping crane and the American burying beetle. Our construction length was estimated to be about 4 to 5 months. So if we were to start in the later part of the year, around November and December, we would ideally avoid the areas of concern where a lot of these are flyover times or nesting times, and we would only interrupt the early spring. In that, we would employ standard mitigation techniques. We would minimize potential nesting areas. We would observe for like American burying beetle bearing locations, and we would ensure that there's endangered species training for the identification and not handling of these species of concern.
Thank you, and if you guys have any questions, we'd be happy to answer them.
Good stuff. Took me back. Any questions for the design group? I'm not gonna let you go to lunch. You ask at least one question.
We like questions.
Thanks, Mike.
Has the job been built yet? Has this bridge been reconstructed yet?
They're currently doing the designs at Freeze and Nichols.
Oh, so they're not gonna use your design?
My bad. No, they are not going to use our design, even though they probably should. But I think Freeze and Nichols is they recently did their 90%, but I don't know.
Yeah. So what they do each year is ODOT gives us a project to do that's actually being designed or has been, and then they let us go through the process of going from 30 to 90, and so we can learn how to go through a full design process. So they don't actually do our design, but it'd be cool if they could.
It looked good.
We can't afford you. Any other questions? Yes, sir.
I don't really have a question, but y'all did a really good job. So the geotech was exceptional. That's all that really matters. So.
We'll have to let her know. She's currently at the concrete canoe competition.
Yeah, Elizabeth, she was emailing me questions and stuff, so she applied everything really good. So. Yep.
That's awesome. Anyone else?
Yeah, great presentation. What was the biggest constraint you guys found that was hardest to work around?
I like how we all shared a look right there, and we all agree it's software. Open Bridge, shout out to Damien, said it the best. It likes to crash, especially when you do modeling. It has fun with that. But I'm also one of the ODOT design squad members, so that gave me experience with that Open Roads and Open Bridge for the software that we use for this project, especially like ODOT standards. So shout out to Damien and Nayeli. They are wonderful to work with.
Any other questions? Now, I heard a rumor that, so you're working over 2 creeks. One of them has a name, the other doesn't. But I hear you guys are trying to name the other creek. What's the story behind that?
All right, who told you? Dr. Harvey, I'm looking at you. Okay. Oh, Cassandra. Okay. All right. So, I am a person of whimsy. I like to have fun with stuff. When we learned that this was an unnamed creek, I emailed the United States Geological Survey and was like, hey, this is unnamed. Who should I talk to? And they're like, not us. In fact, the Great Seminole Nation of Oklahoma is who I needed to talk to. So, like I said, person of whimsy, I like to keep going. I emailed the Council of the Seminole Nation and said, hey, the name of our group is Red Dirt Designs because we are Oklahoman. Well, some of us are Texan. But our land is red. It has red dirt, beautiful iron oxide in that dirt, but that is what we are. So we wanted to, just like our name was an homage to that, we wanted this creek to have that name as an homage to that. So I emailed and I was like, hi, I'm with the ODOT Design Squad. Not ODOT Design Squad, my bad. I'm with the Capstone Design Squad. Not ODOT, ooh. And I was like, we want to propose Red Dirt Creek. And the chief of the Seminole Nation, Chief Yesleth, replied and was like, thank you for bringing this to our attention. We didn't know there was an unnamed creek. We have translated some options into Seminole, and we would propose them. And the one that we chose was Kankati Hachi, which means Red Earth Creek. So they are still going through their legislation on that, and we are in discussion. We actually have a meeting with them this Friday. And it's been a wonderful experience. I myself am a member of the Choctaw Nation of Oklahoma, Halito. And I take great pride in that. As I also participate, I will be next year's president for the Advancing Indigenous Science and Engineering Society here on campus. I would definitely love to talk to some of the native transportation officials here to see if we can have some meetings or stuff this next year. It's been a journey of connecting my engineering identity with my indigenous identity and just being an all-around Oklahoman.